Okay, here's our lesson for sections 2.1 and 2.2, and we're going to be talking about modeling with expressions and equations. In general, modeling is going to generally tell us that we're talking about word problems. So we're just talking about how to use algebra to represent those things. Remember, expressions don't have an equal sign, and equations do have an equal sign. That's our difference there. Some of these keywords you should be familiar with. Some of them are so simple you don't even need to write them down. But I do want to highlight just a few that I think you should probably get down in your notes. All right, so the words that are underlined are words that sometimes we don't recognize as being addition, subtraction, multiplication, or division. So those are the ones that I might have listed next to each operation. I don't think you need to write plus to tell yourself that's addition. I think that's something you already know. One more that you need to add are rate words. So, and rate words are going to be words that indicate that we have a number with a variable. So rate words put a number with a variable. All right, such as like 2x, that might be what that looks like. And some rate words that you need to look out for are per, for each, or for every. Those are all rate words. There's a few more, but those are the ones you're going to see the most often. All right, so this first example is just going to ask us, take a second to read the problem actually. And then this first question is going to ask us, what does the expression represent? So really they're just asking us to match some of the word problem with the expression that's already written. So if you have read through this, 3p is going to represent this $3 per package. Remember I told you per was a rate word, so it's putting 3 with the variable p for packages. Okay, so $3 per package is my 3p there. So if you are writing notes in your notes, you may just copy this statement and we'll just write down what each means. So this one is $3 per package. That's what that part stands for. Okay, and then $2.25 per package. So that's what this one is, $2.25 per package. And this time we're talking about a different item. We're talking about pencils, and we know that there are 5 less pencils. So this section right here tells us that we have 5 less than. 2 things that I want you to notice. First of all, you know less. We just looked at that, or fewer. That's going to mean the subtraction. But the reason it's at the end is because of this word than. When it says less than, you move the subtraction to the end. So that you may want to put a little star in your notes. When you do less than, the subtraction goes at the end. So what I mean by that, that's why it's p minus 5 instead of 5 minus p. If that doesn't make sense, we'll look at a few more examples like that in class on Monday. All right, so example B is going to ask us to write an algebraic expression, and we know how to write it in simplest form, but for right now I'm actually going to ignore those instructions just to save time. We'll do that in class together. So the number of gallons of water in a tank that already has 300 gallons in it after being filled at a rate of 35 gallons per minute. So the first thing I want to do is just identify, are there any keywords that I see here? And to me, per stands out as a keyword. Remember, per is a rate word, so that means I've got a rate right here for m minutes. So they also tell me to use the variable m. So when I write this, I'm going to say it already has 300, so that's my starting number, 300 gallons, after being filled at a rate of 35 gallons per minute. All right, which means since it's being filled, that's going to add to what was already in there, and that's 35 gallons per minute. All right, so the next one, the original price of an item. So I have the original price of an item, P. They don't tell me what the price is, but they do tell me it stands for P. Less, so I know I'm going to be using some type of subtraction, and then a discount of 15%. And remember, if you look back at your list, percent is a keyword for multiplication, so just keep that in mind. So that means we're going to start with P, so the original price of an item, minus a discount of 15%. So that means, now you may think, well, how can you subtract and multiply at the same time? All right, so I'm going to subtract the item cost times 15%. And I don't know if you remember this, but when we write 15%, we need to write it as a decimal. So we move the decimal place 2 times. So this is times 0.15. All right, so that's the original price minus 15% times the original price. All right, so this example is asking me to write an equation using only one variable. So I want you to pause and pause and read the questions so that you know what it's asking. Okay, so some things that you may have noticed that were important. First of all, I've got 3 people. They tell me that Carlos has 5 more stamps than Mary. So more stands out to me. That's going to be some type of addition word. Amanda has 3 times as many stamps as Carlos. Not 3 times is going to be a multiplication word that I need to look out for. And then this one we haven't really talked about. I think you saw it on your list. All together told us we were going to add. But what I really want you to take a note of here is that anytime we have a total, our equation is usually going to be set up so that it's some expression equals the total. So anytime you have a total, it's usually going to be by itself. All right, so they're asking us to find the number of stamps each person has. So the first thing we want to do is just kind of set up a bare bones of what this problem is asking us to do. So we said normally what things are going to go together to make the total? Well, that is the amount of stamps that Mary has plus the amount of stamps that Carlos has plus the amount of stamps that Amanda has. All right, that's how you would figure out all together, is you would add their 3 numbers. Well, they want me to only use one variable. So I'm going to kind of work backwards and figure out who do I know the least about. And if I read my 2 sentences, to me, I don't know anything about Mary. So Mary, I'm going to call X because I don't know anything about her. So X, if we're defining our variable here, X is the number of stamps that Mary has. All right, so now let's go back and see if we can do anything else with that. So I know how many Mary has. Theoretically, she has X. Carlos has 5 more stamps than Mary. That means Carlos has the same number of stamps that Mary has, X, plus 5, because he has 5 more. And then Amanda has 3 times as many stamps as Carlos. So Amanda has 3 times the number of stamps Carlos has. And we said Carlos's stamp count was X plus 5. All right, so take a second to just make sure you understand where all of that is coming from. And if I rewrite that, now I do want you to know, anytime it says to write an equation, unless it tells you to simplify, you need to do the least amount of work possible. So don't combine anything, don't distribute anything, just write the most basic version of your equation. So I'm just going to rewrite X plus 5 plus 3 times X plus 5 equals, the only other thing I need to do here is enter my total, which is 100. So the 2 parts to my answer are going to be X stands for the number of stamps that Mary has, and my equation over here that I just wrote in the end. All right, here's our last example. So again, I want you to pause and read through, make sure that you understand what the question is asking before we start and write the equation together. All right, now that you've read, it says that Janine has job offers at 2 different companies. So one company, all right, so this is all the information for one company in orange, and then the other company, we have that information for. The question is asking, when will they be the same? All right, so it's when it says when will they be the same, that means when will they be equal? That means when will one company equal the other company? So that means we need to write expressions for each one and set them equal to each other. So for the orange one, when I go back and read, they give me a starting salary of $28,000 with a raise. Okay, so raise tells me I'm going to be adding of $3,000 each year. All right, remember each is one of those rate words, which means I'm going to end up doing multiplication with a variable there. So for one company, that means I'm going to have 28,000 with a raise of $3,000 each year. And I'm going to use Y to stand for the number of years. Okay, when we read through the blue, it says a starting salary of $3,600 with a raise. So again, I'm going to be adding $2,000 each year. Again, I'm going to have a rate. So that's $36,000 with a raise, so plus $2,000 each year. Now, we're going to work on solving this one in class tomorrow and kind of answering the rest of the questions. But for right now, all you need to do is have this right here. And the only other thing we need to do, anytime we write an equation, we need to also say what the variable stands for. So we just need to make a side note to ourselves that Y stands for the total number of years. Total number of years. All right.